today is a relatively short topic, leaving us plenty of time to get the labs and the build checked off. So today we're going to look at installing VMM, or System Center Virtual Machine Manager. And basically, the aim of this today's topic is to look at integrating System Center and server virtualization. So like I've been talking about, that System Center is a suite of tools, that actually manages your whole virtualization infrastructure from the one place, rather than managing each HyperV each HyperV host individually. So I know you've actually opened the HyperV management console and added the other server in, and you're sort of doing it from the same window, but really that you're still creating virtual switches on separate HyperV servers, and you're doing things individually on each HyperV server. So what we're talking about with the System Center Virtual Machine Manager is the ability to manage your infrastructure from the one place, creating a virtual networking that's done once and it's applied on all the hosts that you choose. So today we're going to give you an overview of the System Center Virtual Machine Manager. We're going to try installing it in the lab, and we're going to add hosts and managing the host groups, which the name suggests, groups are hosts. Let's get into it. So what is Virtual Machine Manager? Is similar to the vCenter server in VMware. So we've been saying this quite a lot as we've been going along. It compares to vCenter. So vCenter, so VMware. vCenter is a management server in VMware. Okay, so the ESXi are the hypervisors, and vCenter manages those hypervisors. So in that sense, VMM is a management server. It doesn't do any virtualization itself. It manages the virtualization servers, or the hypervisors, which are your Hyper-V servers. So VMM features include multi-host support, which, what does it mean? It means it can manage Hyper-V hosts, it can manage Citrix and VMware. But when we say manage, it's really limited. To be honest, in order to manage as the VMware host, you would still have to have a vCenter server, and you're using VMM to manage the vCenter server, which actually manages the Hyper-V, the VMware host. With VMM, there's some features that we were able to use that we couldn't use, or we couldn't use to the extent we could previously. So there's that intelligent placement. So one of our topics will actually be creating a new virtual machine. Once we've decided, once we've got the hosts in the VMM, intelligent placement basically tells us where to put the virtual machines. Obviously, if you've got 10 hosts, and let's say 9 of them was very utilized and 1 of them wasn't, then obviously, common sense would tell you to put on the one that's not heavily utilized. But the intelligent replacement can be configured so that it's actually, you don't have to even choose, it just goes there. And obviously, we're not even talking about just utilization, that's the easiest way, but there's suitability as well. So it's going to give you a rating system of the hosts and how suitable they are for this virtual machine. So if you've created a virtual machine with lots of CPU cores, it's not going to place it on even though if the resources are free, it's not going to place it on a host that can't cope with the amount of CPU cores that you've actually implemented. There's also dynamic optimization, which we spoke about previously. This is where we dynamically or on the fly balance resource utilization. So basically, if we have 10 hosts or 2 hosts, let's start with 2, then one's 75% utilized, one's 50% utilized. You would assume that some of the workload, so that's not fair, obviously, and some of that workload will be shifted from the one that's 75% utilized to the 50% utilized, hoping to achieve something that's equal across the board. And obviously, the reason for this is so that the resources are utilized more strategically and it's wisely, and so therefore no virtual machine or its services as hosting is running out of these resources. And it does this, achieves this by using the live migration feature to move the virtual machines from the busy host or the utilized host onto the less busy host, the underutilized host. There's also App V support, and we'll talk a little bit more about App V. It's not a very big part of this subject, but App V is similar to VMware vApp in the sense that instead of actually treating individual virtual machines as individuals, we're able to group virtual machines as an App V, which means we treat them as a group of virtual machines in one unit. So when we start up this App V, it will start up all the composite virtual machines that comprise that's in its group. It even has the order of starting up, and when we take snapshots, for example, we will take the snapshot of all the component virtual machines. And live migration, we know quite a bit about that already. There's delegated administration, which means that we can give other people levels of access, okay, levels of control. So what does that mean? That means that we, as administrator, we don't have to do everything. We can give certain people a level of access so that they can actually manage specific aspects of the virtualization infrastructure. We don't have to give them administrative access. We don't have to give them full access. We can even just give them enough access so that they can actually just mount a new CD-ROM in the virtual CD-ROM of the virtual machine. And that's as fine-grained as we could set that up. This VMM, obviously, we've been talking about moving to the cloud, Azure cloud, Microsoft Azure, and basically this VMM is a step closer. It actually allows us to have the cloud infrastructure and service management. So it allows us to, take the next step. So if you don't know Microsoft's philosophy or strategy, it's to get it into their cloud. Okay, they sort of give you these services that you can host yourself, but their strategy is in the long term is to hopefully that you'll see the benefits of virtualization, and not only virtualization on premises, but offload that workload to the cloud so they can actually, instead of charging you for a license fee, they charge you an ongoing subscription. And the world's gone that way, if you haven't noticed already. With the Office 365, it's subscription based, and there's so many services that's in there. And obviously, with the cost of having private data centers or your on-premise stuff versus the actual yearly cost of using the cloud or cloud infrastructure, you can see that a lot of companies will actually opt for offloading that cost. Obviously, over the long run, it'll probably cost more, but in the short term, it's going to cost you less to have a workload in the cloud than it is to set up your own private hybrid cloud. But don't forget, it's also offloading the headaches. Okay, so the physical aspect of it, you don't have to worry about the hardware, you don't have to worry about end of life, you don't have to worry about the redundancy of the hardware and so forth, because all that is actually what you pay for when you're paying for that subscription. So managing server virtualization using System Center App Controller. So there's also an App Controller. So today, if you haven't noticed, I'm giving you a bit of an overview of the VMM, and as we're going through the different topics, we'll actually look at some of these a little bit more detail. So the App Controller replaces the new deprecated VMM self-service portal. So basically, this allows the owners of the virtual machine, not so much owners as in your company owns it, but obviously people who are interested in the virtual machine or the services of the virtual machine to actually self-serve. Let's say you have a webmaster. Okay, that person who's in charge of the websites, designing it, administrating it, whatever. But you may have a bunch of virtual machines which are web servers. So this self-service portal may allow this webmaster to create new instances of virtualized web servers, and to actually administer those to a certain level. So this allows us to provide delegated access to private cloud and public cloud resources such as virtual machines, such as services, such as templates and images. So think about that scenario where the webmaster needs to get a new website going. Well, he has the choice, or he or she has the choice. They could choose to create a brand new web server virtual machine, use an existing virtual machine, or add an additional service to the existing virtual machine. So when they do this, they could just, if it's a service or a virtual machine, easy, they just get access or delegate permissions to those virtual machines and services so that they can actually provision a new website. But if they had to build a brand new web server from scratch, they could do it the manual, slow way where they have to do everything, or they can use the idea of the template virtual machine, a bit like how we're using the Golden Mother as our template virtual machine as a starting point. But these templates and images allows the quick deployment of these new virtual machines in the cloud or on your private cloud with certain things already done. So it also allows administrators to migrate between the VMM and Microsoft Azure and service provider data centers. So it's saying that this allows us to move our services or entire virtual machines from our private cloud to Azure or another service provider's data center. With VMM, there's also what's called an operation manager, which provides application monitoring in both the private and public cloud. So application monitoring is really monitoring the services. Okay, so if we have a web server again, how do we know that web server is actually running? You know what I mean? How do we know? We assume it's running, and unless we're manually refreshing our web page, it's not actually going to tell us it's running. It's probably in those situations, a lot of times you find out your web server's down because you get complaints that people can't get to you if you do nothing else. So, and that's the worst way to find out. So basically this application monitoring actually actively polls these services to make sure that they're actually running. Okay, so there could be just like a HTTP GET, GET operation that it sends on a sort of regular time span, and obviously if they're getting a response from that port from your server, then it's going to be okay. If it's not responding, then it might be down, and so forth. There's a dashboard that allows us to have quick glance information. There's health monitoring to tell us how healthy our virtual machines or services are, and there's alerts which actually generate by things events. So I've sort of talked about this a few times, but when you're actually employed as a ICT personnel or someone who's working in IT, you don't actually build servers or configure new sites or new services every day. Most of your job is to actually handle requests and handle jobs as they come up, and alerts are the source of a lot of jobs for you to investigate. And having this monitoring and alerts allows you to ensure that what you do have running or configured continues to run and configured and is working properly. And obviously, like we talked about before, it's all about uptime. By having these monitoring and addressing alerts, we are able to take preemptive measures sometimes to actually ensure that our services and servers are actually running and will continue to run. There's agent and agentless monitoring. So agent means there's a bit of software. Okay, so like if you look at the VMware tools, that would be an agent. For those of you who've done the SCCM, you would have remembered this, that there's what's a SCCM client, which is an agent that's installed inside the operating systems, and it reports back. So when it says agent and agentless monitoring, means it can use agents to monitor certain things, and it can be no agent or no software required to be installed in the operating system that you're trying to monitor others. There's also fabric monitoring. So fabric is a new term. So when we're talking about VMM, we are talking about many Hyper-V hosts. Okay, you would not deploy VMM in a system or network or infrastructure where you have less than 25 hosts. it doesn't make sense because it's an extra expense and you wouldn't get the full benefits of VMM in that situation. So VMM is managing all of these things, and what we do is we combine the resources of all these hosts to become a sort of virtualization fabric, because a piece of fabric just continues on. It's you don't know about the individual threads, you don't know about the individual weaves that make up the fabric, but it's a continuous plane of resources, if you like, and that's why it's called fabric. So by integrating Operation Manager and VMM, you can monitor the entire virtualization environment. Integrating System Service Manager. So Service Manager, with Service Manager, you can implement service management as defined by ITILs. So if you've never heard of the ITILs, I'm sure you would have. You would have did some of this in the 4 PICTS, which is the help desk, but ITILs is basically a framework that allows us to set up and run a service desk to the standards. Okay, so it's all about logging jobs, job escalation, and how a service desk and services should be actually done. So this System Center Service Manager allows us to use this as part of the ITILs. You can use in the built-in process management packs to provide processes for defining templates and workflows, implementing change requests and change request templates, manually designing activity templates, and enforcing compliance. So don't forget this. When you're working as a team, as in an infrastructure, you're not just doing things how you like to, when you like to, and you make changes because on a whim. Because the problem is when you're working in a complex environment, minor changes might have unconsidered consequences. So, for example, if you reconfigure the DHCP server to exclude a certain range of IP addresses because you needed that for something, but if it turns out that people were already using their IP addresses in other filtering, in your firewall filtering, for example, then as a result, those filtering rules may not work anymore, or they might be filtering the wrong computers as a result of you changing the DHCP configurations. So therefore, without considered change requests, then you could be causing as many problems as you're solving, if not more. So this whole ITILs framework is all about where it's all documented. It's not a cowboy making these decisions. It's a proper workflow or a method of making changes, designing processes and so forth. But Service Manager allows you to have this job tracking, if you like, process management pack. So you open a job, you close a job, you escalate a job, and so forth. We can also use System Center Orchestrator to automate tasks. So it's a lot of the things is all about automation these days. So Orchestrator, it compares to VMware Orchestrator, funny enough, automates processes across systems and platforms and cloud services, and it allows you to automate best practices. It connects to different systems from different vendors, implements built-in integration packs, implements end-to-end automation across multiple System Center products, and enhancements in System Center 2012 and obviously the new ones increase multiple runbook workers that combine with Windows Azure for Windows Server. We can use these runbooks to automate tasks as well as with PowerShell. So we're not going to cover this too much in this subject, but just be aware that there's a thing called Orchestrator that allows us to automate our tasks. Let's say if a lot of your task is to create, again with that web server scenario, you host many web servers. You have webmasters that control these web servers and the content of the websites. If they need to get a new website going, which requires a new web server, they use a template to deploy them, and then to actually and the webmaster places the web files somewhere. But if it's a common occurrence, let's say you are a web hosting company, if it's a common occurrence, yeah, it doesn't make sense that that person, the webmaster, has to do this each step one by one. Okay, manually, one by one. Let's say you're having like your web hosting company. You might be getting 1,000 new websites coming online, maybe another 500 dropping offline because they're no longer used on a monthly basis. You don't want to be doing all of that repetitively manually. So what these runbooks can allow you to do is actually automate the creation of a new virtual machine from a template, the creation of a new website by accessing files at a certain place, or something like that. There's also the System Center Data Protection Manager. So we sort of talked about this in 5ICW subject. So in 5ICW, we talked about the Microsoft backup software, which is per server, per computer, and it's on every Windows computer, to be honest. But the DPM was a system center tool. So it's again something that's going to, instead of backing up per server, it's something that allows you to configure backup for the whole network. A single point where you can manage the backup or data protection of the whole network. So the DPM, Data Protection Manager, provides disk and tape-based backup protection and recovery. You can recover from bare metal servers and desktop running Windows operating system. And it's a centralized management for DPM Administrator Console. It's role-based access permissions, allows you to distribute backup and restore management to other people. But you could also use this DPM to back up with Azure, so integrated with Azure Backup. It also can be used to back up SQL Server clusters, and it also can be used to back up virtualization deployments and Linux virtual machine link up with the Linux virtual machine backups as well. So using Windows Azure Pack for self-service capabilities provides the following capabilities. There's management portal for tenants. So tenants are basically the people who pay rent. So they're the people that are using the hosting capability. So again, all along we've been talking about your private cloud, how you could be a hosting company. Okay, so management portal for tenants means it allows the tenants to interact with their rental, which is your resources or virtual machines on your resources. The management portal for administrators gives you a management portal for administrators as well as service management APIs. So APIs are application program interfaces. So basically what that means is it's a way that your programs can be plugged into by other programs. It's a bit like how you have a car and a trailer. If you have a car and a trailer, they can't really connect to each other directly, okay? Because there's no interface between the car and the trailer. But if you have an interface by installing a tow bar on your car, then that is like an interface between the car and the trailer. So it allows something else, something additional, which is not part of your default car, to come in and connect with your car to add more functionality, which in this case is a trailer. Could be a boat trailer, could be a caravan, could be all sorts of things you can interface with that tow bar. But this API in programming terms allows third-party tools, basically. Okay, tools which are not from Microsoft. It could be tools that you create. It could be tools that another vendor creates because they want to use their customized software or their software to interact with your systems, and this API allows them a way or interface to connect. Microsoft Azure website and virtual machine access to private cloud, so that gives you that ability, and service bus communication between applications, and allows us to automate and extend custom services. All right, let's keep on going. So introducing the System Center VMM, it's a significant enhancement in the following areas. So like I said, this is not for a small infrastructure. Okay, it's not for a network or a virtualization infrastructure where there's not many hosts. So basically, it's enterprise class form, and it supports up to 1,000 hosts per VMM. And on these 1,000 hosts, so each one of these hosts is a HyperV, and on these 2,000 hosts, you can have up to 25,000 different virtual machines. There's supports dynamic VHDX resize, that's the virtual hard disk. It allows for automatic upgrades of Hyper-V clusters with live migration. What does that mean? It means that Hyper-V gets outdated as well. But we have a lot of Hyper-Vs, 10,000 of them, and we've got, let's say, 25,000 virtual machines. If we want to upgrade the Hyper-V, obviously that needs a restart, doesn't it, of the Hyper-V server. So a lot of times these Hyper-V servers are actually those nano servers, so you don't actually install the update to the servers, you just basically provision a new image and deploy a new image to the hardware. So that requires downtime. Okay, so what this automatic upgrade allows us to do is that if we're not gonna upgrade all of the Hyper-V in one go, bang, done, because that means everything's down. Instead, what they're going to do is it allows you to do a rolling update, which means that, hey, we can afford to take 6 of the 1,000 Hyper-Vs offline to do update. So what we'll do is we'll live migrate the virtual machine, which is on those 6, to other Hyper-Vs right now, turn them off, apply the update, bring them back on, then live migrate back onto these ones, freeing up another 6. And the process rolls across and updates all of the Hyper-V hosts eventually. It also provides enhanced support for Citrix and VMware hosts. And when I say support, it's not, you can't just suddenly plug a VMware ESXi or a Citrix host into the system and expect everything to work together. It's not like that. Okay, it just allows you to do some basic things in those areas. It has simplified provisioning and migration, so it has storage improvements as well as bare metal provisioning. So remember what I said about the nano server? Basically, nano server is a small, just enough operating system, and it's the most common way of deploying Hyper-V on physical machines. So they are image-based deployment. What does that mean? That means you don't go through the installation process like you normally do. What you do is just basically write this image onto the media, which is the hard drive of the server, and then it boots up. Okay, so there's no installation process. It's just like you burn a DVD from a ISO, and you end up with a DVD. You basically get this image of this nano server, and you put it onto the portable hard drive. Not portable hard drive. You put it on the hard drives of the server in bare metal. Bare metal is where there's no other operating system, or you don't care about the other software that's on there. You're going to blow that away and put it on there. So basically, it writes this image onto the hard drive, and then it boots up with everything on it. Okay, so it supports multi-tenanted cloud infrastructure. So multi-tenanted is where you're hosting services or virtual machines or something else for many different companies. And it supports provisioning of the Azure infrastructure as well. Fabric management. So we mentioned the idea of the fabric. So the fabric basically is everything, all the virtualization infrastructure. So the fabric includes network, storage, host computers, and groups, as well as the Windows services, which is a way you might want to deploy the virtual machines, and the WSUS servers for updates. It basically aggregates. Aggregates means combines all the resources. It abstracts. Abstracts means it hides. It sort of yeah, hides. It sort of hides in the background in the sense that you don't need to know how it does it. You can't see it working away, doing combining everything, but it presents it to you as if it's one into resources, and you just use these resources. But how it does it is happening in the background, and it's hidden from you. That's what abstracts means. So it aggregates and abstracts everything into resources that can be consumed and deployed. So that's why it's one continuous fabric now, combining all the resources from all the hosts and so forth. It's accessed by the administrator and designated user roles in the private cloud resource allocation. So if you look at this, in the fabric management, you manage the network, the power, storage, the updates, dynamic optimization, your hosts, your bare metal provisioning, and monitoring integration. So if we look at how it works, so we have these HyperV hosts. We're familiar with that now. Then we have the VMM, which manages all of these. Then as an administrator, you use the management console to interact with the VMM. You also has a SQL database that's critically important. So a lot of these high-level services. So for those of you who've done the SCCM subject, you remember that we installed SQL. So a lot of these high-level services, the system center type services, require SQL. The VMware vCenter, for example, also requires SQL. It's the same level. So basically, this is the SQL. If you don't know what it is a database service, and it stores the configuration and configuration information in the SQL server. And we need a library. The library can be on the same server. In fact, the SQL server can be on the same server as the management server, but it's not recommended that it is. But in our lab, it will be. And the library server can be on the same server, or it can be on separate servers. But the library provides resources such as ISOs, templates, and all of those kind of things that we can use in our virtualization infrastructure when we need to use it. There's also app controller we spoke about, which gives the self-service to that web server, webmaster, to be able to manage the web services that he owns, but nothing else. And we can delegate permissions to him or her for the level of access. All right, so if this is a management server that can manage 1,000 hosts, what if we need 2,000 hosts? Well, we just add another management server, and then we can have another 1,000 hosts. Or another thing is that if we only have one management server and we're managing that 1,000 hosts, what if something happens to this management server? So what we can do is actually just load balance with clustering. Failover clustering so this is not the HyperV failover clustering now. This is the Microsoft clustering, and we can cluster the SQL, can cluster the VMM, we can cluster the library cell, even the app controller. So there's no single point of failure, and this compares to the vCenter heartbeat. Determining the topology for a VMM deployment. Okay, so we have the VMM server. This is our console, which basically means our administrator's workstation that we use to manage. We have the SQL database and the library server, which, like I said, has ISOs and other resources we use in our virtualization. Then we plug in the WSUS server. We all know that that's for updates. WDS, for those of you who did the SCCM, is for deployment, Windows deployment services. So for new deployments. We plug in the HyperV hosts, more likely, possibly Citrix hosts, probably rarely Citrix, rarely ESX hosts. But if you had this ESX host, you still need the vCenter, which is being managed by the VMM anyway. So having these type of hosts is very rare. Most of the time you'll have Hyper, but this is just possible. And then you have the cloud, your app controllers, which actually allows for self-service and possibly branch office VMM servers. So basically, you can see that the VMM server is the center of everything. Okay, we're not going to go crazy and deploy all of these things in our labs. What we're going to have is a VMM server. We're not even going to have a WSUS or WDS server, because that's a different aspect. That's all about deploying the operating system of these hosts as well as these virtual machines. So basically what we learned in the SCCM with the deployment of operating systems and so forth can be applied here in the virtual world as well. And then obviously our virtual machines can use VMM to integrate with Azure, which is the Microsoft ultimate goal for us. Adding hosts and managing host groups. So host groups, as the name suggests, it's a group of hosts. And when I say host is basically a Hyper-V server. So what does it do? It allows collective management. So instead of actually managing per host like what we've been doing, this host groups allows us to manage this group of hosts in one go, in one click. And what we configure for the host group applies to all the members or all the hosts. So it can be, you can have nested host groups. So you can have a host group which is for web server virtual machines. Okay, web server hosts, and then within that you might have like the SQL host as a child host group, but the inheritance applies, meaning what you configure the parent flows down to the child. So there's configurable properties include the naming of the group and moving of the group. Allows unencrypted file transfer. There's also placement rules we can configure. Remember we talked about like the host affinity and host anti-affinity. So a virtual machine must be on a certain host, should prefers to be preferred host, must not is anti-affinity, or should not, it means not preferred. There's also host reserves, so we can reserve various resources for the host alone. So we might have to do this later on when some of our labs don't work correctly, because there may not be enough resources for our hosts to use for the virtual machines. And these resources are your CPU, memory, disk I/O, network I/O. There's dynamic optimization. We can configure these for determining the load at which we would apply optimization. So if the load is if the load is not too different, for example, sometimes by actually optimizing, by moving the virtual machines around, it creates more load than you actually on the systems because of that action. So we have we can configure the resource defaults. The power optimization is included. So power optimization is a little bit different to dynamic optimization in the sense that power optimization allows us to turn off hosts in less busy periods of time and consolidate the virtual machines onto a smaller number of hosts. We can configure the network, so we can assign varied network resources, IP pools, load balancers, logical networks, and MAC pools. So we'll be doing that later. But when we create a network, for example, a virtual switch, for example, they're not called virtual switches anymore, they're logical networks. When we talk about that and we create it, it'll be like we'll be configuring the logical network for all hosts in this host group rather than one at a time. Storage, we can assign storage pools and logical unit resources. And we're deploying Hyper-V host to bare metal computers. So bare metal is where there's no operating system on the hardware. So physical computers without an operating system installed and deployed as a physical host. So the requirements are we have a network adapter capable of PXE, pre-execution environment, which basically allows it to boot off the network. So for those of you who did the SCCM subject, you'll probably be familiar with this idea. So we can create a PXE server in the domain. We can set our BIOS to boot from the network, and we can have the proper credentials. The host profile must already exist, so these hosts must already exist, and an image must be defined for them. The MAC address is discovered for the static assignment, so obviously if we have some assignments for this host must be use this specific image, then we can map it to a MAC address. The VMM SP1 and R2 offer deep discovery, which automates IP assignments, and we can use Fabric Workspace and add Resource Wizard to launch the deployment. So basically, what I've been saying along the way is that Hyper-V hosts are cattle. Okay, you probably heard me say that a lot of times. What it means is cattle for a farmer is just a resource. If it gets sick, if it's got a sore leg, and instead of trying to nurse it back to health, like you would if it was your pet dog or something like that, the farmer might say it's not worth the resource to actually nurse this cattle back to health. So they might just put it down. Okay, as harsh as that sounds, when you're a farmer, these cattle are a resource and it's a business. For us, what we're saying is that in virtualization, these hosts are important because they provide a resource to be able to do the work, but essentially a Hyper-V host is not important. The virtual machines, the services they run, are a lot more important than the Hyper-V hosts. So with this, the ability to deploy Hyper-V hosts in bare metal means that if a Hyper-V server gets sick or is not running properly or it's got problems, why troubleshoot it? Why take the effort? Migrate the services the virtual machines off it, put it out of its misery, and redeploy a new, fresh operating system hypervisor onto the physical machine, and then you've got a brand new, brand new and shiny Hyper-V server, and then you can move the virtual machines back. So we don't spend any time worrying about this host or troubleshooting it or spending much time on it at all besides basic configuration. Okay, so that's what having this bare metal, the ability to have that WDS as well as bare metal PXE deployment allows us to treat these hosts like cattle and just blow them away when they're not useful anymore, redeploy, and they become useful again.